This conference will now be recorded.
So welcome everyone. So today we'll have a presentation about the OCP education project. Is that correct, Cliff?
I wanted to do two things. One, introduce everyone who I haven't had a chance to talk to yet. I'm making my round of the project groups on the new market intelligence functions for the OCP. And specifically spend a little time on the educational webinar program as something for this group to consider going forward as you think about the deliverables and what you want to achieve for 2022.
Yeah. But before that, we want to basically have a presentation about the like time synchronization, how we're looking at time synchronization going basically to the end users, which it will be a presentation between me and Julian, and then we basically will have Cliff presenting your remarks about the education thing. Okay, Julian, I'll make you a presenter and then we can go from there. So Julian is a colleague of mine, and I will let him actually introduce himself.
Yeah, so I'm a network hardware engineer at Meta, so working on PTP deployment in our data centers right now using the Timecard and OpenTime server. And then I'm also working on developing a wireless synchronization scheme to eventually get to the end user. So end users are able to synchronize like your home PC with a GPS time. So if you can make me a presenter, then I'll share the slides.
I will do that. And Julian, if you can improve your mic or simply put it closer to your mouth, I think.
How about this? Is that better?
It's much better, yeah. All right,
Okay.
You're the presenter.
Okay, got it. Okay, are you able to see my slides?
Absolutely.
Yes.
Okay, so we'll be presenting about getting precision time synchronization to end users today. So I'm Julian St. James and Ahmad here. So Ahmad, do you want to take these early slides?
Sure. I mean, like you guys are familiar already with the why do we need synchronization in data centers, which we discussed it several times on like databases and different like let's say things that we can do. Let's say with consensus inside the data center. Let's say I don't know managing traffic between switches and so on. The applications are a lot, and as we basically have this available, there will be definitely more and more things to come. But we always get this question: how about end users? So next slide, please. So why do we need first place? Like why do we need synchronization by end users? So well, the simplest way to answer this is we want to timestamp events by the end user. So in order to make it fair, like let's say when you have like various things, you have like scarcity of some resources or so on, you have the end users, you want to have the action for the end users basically to be considered and placed in an account rather than like the accumulation of that command going through a network and the latency and you name it. So we want to have basically the things timestamped there. Also, there are various things like methods, let's say, where you are trying to defy latency. I mean, not defy, it's like more compensation for latency, which they rely on prediction, estimation and prediction. Let's say, for example, in a case of two players are, I don't know, let's say playing some game, let's say, I don't know, some racket or something, and you're trying to have in this like virtual world, let's say, the simulation of presence. So with presence, you're trying to basically defy distance, and defying distance goes with something very important. Like you can't really overcome the speed of light. You cannot overcome latency. All these things already exist. So what can you do? So there is this famous saying: if you want to control it, if you can measure it, you can control it. So if you can measure latency properly, and you can basically have proper estimation of certain motions or like whatever is there, and you project, let's say, the things how they are going to look like rather than how they are at the moment, perhaps you can overcome most of these things. But again, an essential part to this is you need to have the like the precision time delivered to the end users. So the third one is perhaps like network traffic management now from the end user. Now the end user knows, like, let's say what's going on, let's say from the network, because everything, let's say, is somehow, let's say, measured and so on. Can go both ways, you know, like the network can figure out like, okay, this amount of data is going to come, and like a lot of these, like, let's say micro scale, let's say players that together they might have like a bigger effect on the network. They can, once you can measure them, you can manage them. And then one more important thing is, in my opinion, the enhanced security. So if you can have precision time, let's say by the end users, then you can time, let's say, a packet on the departure and the arrival, and you can overcome, let's say, problems with a middleman attack or something. You always know this is what's going to take, let's say, for a packet to travel from A to B. It also goes both ways. Now, you want to have, like, let's say, once you have the timestamp of the event, like the events happens by the end user, you want to have also some security there that, let's say, that precision time that the user is claiming is actually true, is not a spoof thing. Because let's say you have, I don't know, more serious application, let's say stock market or something, and let's say these methods become so popular that they want to get there. Of course, the most important thing at that point will be, how can you trust this time from the end user that is right or not? So there's all other challenges, how you want to, let's say, go or validating the time that the user is presenting as a timestamp for the event that occurred there. So one of those applications that is kind of less serious but same challenging is this mass online platforms. So next slide, please. So mass online platforms, like, you probably are familiar with some of these online games, $1 billion of like industries. Like, you have a lot of users, and they I don't know, basically fight for something in that virtual world. So let's say, I don't know, they're I'm not familiar. I'm seeing, like, I don't know, other friends are playing these games. So I heard, and I know for a fact that they are professional players, that they make even like millions of dollars or whatever for their games and performance. So they end up relocating and, let's say, going and, let's say, living close to the servers in order to gain that extra latency, that, like, basically reduce the latency, so they can have a better lever, like in a lot of these competitive things. I mean, think about it. If, let's say, the server sits somewhere in Korea and you are, let's say, in US, of course, if you live right in Korea, you're gonna have at least, let's say, 100 milliseconds better, like, reaction. Of course, that's gonna be an advantage for you. Or reaction is like 30, like these professional players, like a 30 milliseconds or like a physiological, let's say, reaction. 100 milliseconds is something perhaps can make a difference if, let's say, I don't know, something, and I add to that, that just like the physical ping, let's say, add to that, like the buffering here, buffering there, different, like, let's say, switches in between and so on. So all these things, they can really make a difference for where the player is located. But now imagine if you have precision time by the end user, which is very challenging, we want to talk about it today, then you can timestamp the click by the user, and then the engine, let's say, can run, let's say, 100, 200, let's say, has to be the maximum of the latencies, runs after, and then judges things based on the timestamps that they are presenting when the click occurred. And that's where you see, like, it's very important to validate the time that they are presenting rather than just trusting whatever is coming along. And there are also, as I said, like, other conditions. Let's say you're trying to see which, again, sometimes you are looking for the one that's the earliest, something you look for the one that's the latest. All of these things, you can have a better judgment once you have precision time there. Again, with precision time also comes the probability of if this what is presented, like how much you can rely on it, like statistically, aside from, let's say, some malicious, let's say, modification on something, let's say for, like, I don't know, for gains, which that one is like the validation of something. Next slide, please. So the question is, how are we going to get this basically to the end users? And judging by, even right now, I'm talking to you by laptop, and there is no Ethernet communication, nothing like so. I mean, the last feet, let's say, for this communication relies solely on wireless in today's like technology, either from, let's say, cell phones or like the laptops. So what are we going to do for basically accommodating this last feat of communication and like basically the synchronization? So the GNSS time synchronization methods, like for example what we have in the time card, they require a GPS, like on a GNSS receiver. And GNSS receivers, they always need this connection, physical connection to the antenna. So this can be challenging if you have like a laptop and you say like, hey, now you have to add this, or oh, the antenna is built in on the laptop, but you can use the laptop only by the window or outside. So that's not going to be realistic. So there is a need for basically taking care of this part. So you're looking at Wi-Fi, or like, let's use Wi-Fi, how we're using, let's say, Ethernet and timestamp packets, like on departing and receiving and so on. You see that Wi-Fi will not allow you to go, let's say, less than 5 microseconds or something. And that's because of the nature of how Wi-Fi and the communication in general is designed for. In communication, we're always up to minimize the energy needed per packet rather than the reliability to shoot the first packet and make sure that one arrives. Like, I like to always use this analogy that basically make in communication, like you're like literally trying to go similar to how we have it in laser. You're trying to pinpoint, like, let's say, on a certain frequency. Of course, you can hop around like with all these different methods, stretch spectrum or something. But for sending a bit, we always try to minimize the energy on that certain frequency, and then basically you send it through. Of course, yeah, bandwidth, all the things, but you definitely don't want to go for, let's say, a wide band communication. And this comes down to basically UWB, which like more on Julian will explain, but I just want to like quickly go through it. So like with UWB, you're essentially doing everything you're not supposed to do in normal communication, where in normal communication, you're trying to minimize the energy for a bit and so on. UWB, you're sending like a bit with a lot of harmonics around it. And on the receive, you have multiple receivers to basically receive all possible things that are coming through. All of this basically ends up with increasing the chance that you can actually receive the bit, the specific bit at the time that you sent on the receive side. And then let's say in the environment, you have some absorption for certain frequencies, you have like, I don't know, some bounce back or something, they all can get detected because you have multiple of them going through. I like to, again, use an analogy here. Like, let's say for normal communication or something, they're more like a shotgun, sorry, a machine gun. Like you're basically shooting one bullet per time, while let's say something UWB is like a shotgun. You shoot a lot of bullets at the same time. And then you hope like some of them will make it through. So then you basically know like, okay, that was when the time sync was supposed to be. And then UWB today is mainly used for positioning and finding distances and so on. Like for example, on the iPhone, you have UWB for this air tags you can find and so on. So with that, you can also consider basically the time that is needed for the packet to go through. And the last challenge is basically the high stability oscillator, which we need to figure out like what we can do for it to basically have it squeeze in a small form factor. Because let's say if you want to go for the form factor, small form factor, you cannot go with anything. So I will hand it to Julian to explain more on the UWB.
Yeah, so just to give a little background, like Ahmad was saying on UWB, so this is an IEEE standard, and it uses a wideband transmission, but lower power than other transmissions, so it doesn't interfere. And those sharp edges that you get with those upper harmonics allow the precise time stamping of packets transmit and receive. So similar to what we do in PTP, where you have timestamps of the transmit and receive of packets leaving an Ethernet NIC, UWB has the same function built into it through the IEEE standard already. So a traditional UWB application as part of the IEEE standard is they define a 40-bit counter that runs at 64 gigahertz, so with a resolution of approximately 15 picoseconds. And every packet that is sent or received is timestamped using this free-running counter inside the device. And then they calculate the range between two devices by using basically a pole response method, and then calculating the time of flight multiplied by the speed of light. So in traditional applications, they're doing this in very short intervals. So typically you have a tag in one location, and then it's always blinking, and then another device connects with it and initiates a ranging and then goes into a sleep mode. So you're typically only active or listening for very short periods of time to reduce the overall power of your device. So that way you don't need the battery power that you would need if you're running all the time. But then your accuracy for these replies, because you're relying on timing, it varies depending on your clock frequency. So if you're just using a simple crystal on your board and you have temperature variation, or one endpoint is a different frequency than another endpoint, even slightly, that ideal 64 gigahertz is slightly different between different endpoints. So you'll end up seeing non-accuracy in your measurements of distance just because of your frequency imprecision. Typical use cases for UWB right now, there are quite a few. So like the Apple AirTags, if you ever use them, basically you'll use the app on your iPhone and it'll point you an arrow towards the AirTag. So they're using UWB to tell you the distance. So it'll say like 2 meters. And then it'll also tell you the direction because they're using UWB, Bluetooth, and the gyroscope on your phone. And the same thing is inside the Smart Tag from Samsung. So basically they have a UWB transceiver inside your phone, and then they are pairing with a tag that's out in the world, and together they're able to determine how far away they are from where you are now. And then all the higher level stuff, like they have camera or app, that's all based on the other sensors on the phone. But the distance measurement is done using the UWB timestamping. So how would this work for user synchronization? So the way that this would work for our vision right now is you have a GUG, which is a GPS gateway, and basically it's a UWB host that's transmitting out time. So it has a GPS receiver in it and a UWB transceiver that's being synchronized with the GPS, and then it's broadcasting the time like a PTP Grandmaster, except over UWB frequencies. And so our hope is that one day this will be built into Wi-Fi routers, or even just like a standalone box that you could leave somewhere with GPS reception. And then you don't need a GPS receiver in all of your devices. You just need to listen to this one device, and then everyone would be synchronized over UWB. So for the early prototype I've been working on called a time drive. So this would be an M.2 form factor. This is kind of my first prototype for a UWB synchronization platform. Basically, it has a Intel NIC as a PCIe bridge, and then the Decawave for the UWB chipset. So Decawave is a pretty open, there's a lot of documentation in the public, so there's a lot of reference designs, reference boards, reference software that can use it as a UWB for ranging. And then there's some features that also allow it to be used for synchronization at the hardware level. And then to make it similar to an Ethernet NIC for PTP that has frequency control and phase offset control, I'm adding a DPLL on the board, which will give me that ability to adjust the frequency and phase of my synchronization signals. And then I can feed those into the Intel NIC, and then that would go through the NIC to the PCIe bridge, and then basically work like a time card. So you would have any PHC to sys or TS to PHC operations, you could use the same way as you do with the time card. And then for just a local controller, microchip controller, and SI time OCXO on the board. So I'm actually just finishing up this design, this prototype right now. So if there's any interest in software or even hardware, please let me know. Send me an email. And then just for a high-level block diagram, basically you have a DPLL, which is operating like your time card FPGA, where you have a synchronization control of the frequency and phase of your clock to the Decawave, and also your reset, your sync input to the Decawave. And then you have your I225, which is acting like your PCIe bridge, which also has PTM built in, which was a previous talk from Intel about the PTM benefit of synchronization over PCIe. So that's why I chose I225 here. So with this time drive, hopefully we'll be able to synchronize two devices using only UWB, and then also synchronizing using PHC to sys to another PCIe device without any degradation. And Amma, do you want to mention it?
So yeah, you see, like basically we went for this M.2 form factor to have basically the required interface, something more friendly, I'd say, with laptops. And then the reason why we'd like to call it time drive is because we might have the back of it actually just a M.2 storage, and you basically coexist with that, so you don't really need an extra hardware until this technology, I'd say, becomes more popular, and let's say you will have it built in laptops. The same way you have like UWB, let's say, in phones. Hopefully we can see something. Again, this is just a vision disclaimer. It's just a vision, and we like to see if anyone is interested, we can collaborate on this and go further. So with no further ado, let's go for some questions. Any questions?
So far, no questions. Oh, here's one. Daniel is asking, what's the size of the time drive card?
Well, it's a M.2 form factor. It's like these like the storage ones, like the M.2 you can get. Like, so we're thinking most of them are just a single sided. So we're thinking like on the back side of it we can have like all this what you see over there. Again, can be simplified, nothing set on stone. So we are thinking we can have something like that. So it will be just pop it into a laptop, and now your laptop can get in. Again, we have PTM, you can have the synchronization all the way to your processor, to CPU, and then now you can timestamp a lot of these things. Julian, what UWB channel do you plan to use?
UWB channel, I think the Decawave is configurable. The Decawave is configurable, so I haven't fixed that down yet. So just any of the standard ones.
Yeah. So M.2 SSD form factor. Yes, Andy. Like, is that you're asking or you're answering? Andy? Answering. Okay. So and Son asked, like, can UWB transmit? Well, we're not like looking for, let's say, an alternative for whatever is going on with the data centers at this point. So for data centers, reliability is very important. So you have the same method that goes through. This is for end users, as we mentioned. But then, like, there is this piece for now that we're thinking about. Like, basically, my colleague is calling it GOB, like GPS UWB gateway. So that piece perhaps can be built into the router, and then next level, you don't like, hopefully, like, let's say there's enough adoption for this and interest for this technology, we can have from the ISP, basically the ISP will act as the internet service provider, can act as a transparent clock, like GPS is available there for sure, and then you have basically synchronization of the router. The router synchronizes via the internet service provider and then provides the precision time, again, 1 pulse per second, literally, like to all the machines on UWB coexisting with Wi-Fi. Again, this is one like suggestion. It's like again, we're trying to provoke your mind, to think like, what else can we do? It's like nothing is impossible. Any more question? Does this application for security well, I mean, with everything, you may have again bad users that they can take advantage of this. I don't know the privacy risk that you're mentioning. I'd like you to elaborate more on that, Jonathan. But let's say in terms of security, of course, like you need to figure out a way to make sure this time that you're presenting, because again, you go, let's say, for competitive. Oh, I see. UW works well in indoor. Exactly. So this is more for an indoor thing. But let's say going back to the time that you're presenting now, you're claiming something like, hey, you may get an upper hand if you always adjust your time and you present. You always claim that, hey, you clicked something earlier, right? So in order to avoid that, this is still an open challenge. We need to figure out what to do. One, we were thinking maybe sort of a blockchain combined with, let's say, a linearizability test, meaning you should always cross-check with other machines, and you have to have always the linearizability. And if you don't, you get kicked out. So, or like, let's say the hardware needs to be, like, validated with some PTM, like TPMs, like, I don't know. This is really something open to discuss, and we have more questions than answers at this point. How about arranging? Yeah, I mean that one. Still, like, that one is part of the challenges that we need to basically figure out about this. Yeah. Okay. So, any more question? If no more questions, let's go for next presentation by Cliff.
Thank you, Ahmed and Julian. That was really interesting and futuristic.
Okay, thanks. I'm going to share my screen if I can get permission.
You should have it now.
Thank you. And so thanks everyone for your time. This is going to be a little slightly different, not so technical presentation. I wanted to share with everyone a little bit about the new market intelligence function added to the OCP, and also talk a little bit about our educational webinar program, which is designed to help our project teams get more visibility in the marketplace, and also in conjunction help the OCP become more of a visible thought leader in the marketplace beyond the engineering circles where the OCP's brand is very strong. And so let's jump into it. In terms of the market intelligence function, I promised to look at helping with three things when I joined the OCP last September. One, help build awareness for the OCP outside into new markets and new quarters to help with adoption of OCP recognized product, and also help spread around into other corners of the market the ideas that many of you talk about here in this project call. So one of the ways to do that, of course, is to have regular communication with industry analysts that are a very important conduit to corners of the market that don't necessarily get onto our calls. I mentioned the educational webinars. And the other thing we're doing this year is I'm working very closely with Dirk Van Slyke on helping project teams like this team organize an event to be co-located with third-party events. So for example, we're just doing one with the OFC and optical to look at building more of an optical community for the OPC. The software-defined memory workstream in the FTI is looking at doing an event with us, perhaps at SNIA I was just talking with Alan Cantle on HPC about potentially having some sort of co-located OCP event at supercomputing later this year. The other thing is said I would look at helping the OCP launch a certification and training program that could be revenue generating to the foundation. And thirdly, to look at adding an incubation function to the FTI at the OCP, looking at how some of the ideas as they become closer to commercialization could actually end up funded by some of the different investment firm arms of our members. So with that, I wanted to talk a little bit more about the educational webinar program, specifically around the Time Appliance project, which I think is very groundbreaking. And it would be awesome for many more people out there to know what is going on. When I've been briefing the analysts, I've been mentioning the Time Appliance project, and many of them, it's pretty clear they hadn't thought a lot about time, the importance of time, and how the OCP could help. So it would be, I think, good for this team to think about how do we get the word out in a better way, in a broader way than just within the OCP world. And so with that, we have the educational webinar program, which is designed to help build thought leadership for the member companies in the project and for the OCP. And as I said, extend the reach outside of the OCP and promote a broader community. Also, for the marketing folk in your company, it could help generate leads and engage prospects. So the formula is one that I've used in past lives, where we combine a top industry analyst with an innovative content, such as what's discussed in this group, and accomplished speakers. And so these analyst-led webinars enhance credibility to the outside world. The topics are developed collaboratively, and I would love to develop one around time in the data center and the importance of time in the data center. And I would like to work with the project leadership here to do that. We could then find an analyst that's appropriate, and we could target the appropriate communities to take the word outside of the OCP. So, and the webinars typically get results. The webinars are 60 minutes in length. They're done live. They include 10 to 15 minutes of Q&A. We typically have over 400 registrants per webinar. 1/3 attend live, 1/3 are listen on demand later. And for the marketing teams, because we're asking for sponsorship, we guarantee 100 leads in the verticals that they're interested in. So generally the webinars are multi-sponsor. There's a maximum of 3 sponsors per webinar, and the fees per sponsor of a multi-sponsor webinar are $10,000 per sponsor. There is an option for a single sponsor webinar, and we can manage to do that at $20,000, as we have to cover the cost of the analyst plus the cost of the event team here at the OCP. So we currently do have quite a broad calendar of topics generated. The first 2 are sponsored, and we'll be having one on sustainability, sponsored by IT Renew and Submer, going early March. And we have another one on high-speed data center interconnect going in early April. And I'm just about to close, I think, the software-defined memory topic with the SDM FTI with Meta and Samsung sponsoring that. And that would go in early May to support a workshop they're planning to do. So with that, I'm going to suggest to the leadership here and the team to think about an educational webinar sometime in 2022 as a new service that's available to you to broaden the scope of the perception of the work out in the market, and let the market know the really good work that's going on here. So with that, I'm going to stop and see if there's any questions. Oh, one last thing. I will let you know that for those companies that have memberships that have a contribution quota, this will count. Sponsorship counts as one of those contributions. And I think that was what I think I needed to add. Are there any questions about this? I'll leave if people think about it. And the other thing is, if there is interest to develop a topic, I know that most of the folk here on the call are engineering folk, and I'm very happy to, if you give me an endorsement and a pointer to the marketing team in your company, I'm very happy to make that approach on your behalf and explain what we're doing going forward.
Thank you, Cliff. Thank you for presenting the opportunities and options for us. Speaking on behalf of the TAP team, volunteers, and members, this is indeed something for us to internalize and think how we can leverage best, and there are lots of opportunities to engage with the industry.
Awesome. So think about it and you get back to me. Let me know how I can help. It's a resource that's now available to you.
Okay. Any other thoughts from the team? You can speak up. Open the mic. All right. If not, then we can conclude for today. And I appreciate everyone's time and attention. And let's take it next again on the next call.
Right, and Eli, just as you were speaking, someone was asking about getting more information by email. So I'm going to send an email to the team, to the group that was here today with a copy of this presentation and a brochure that we've developed.
That'll be wonderful.
All right, thank you so much.
Thank you.